Hey, fellow mathers, the wait is over. Register today for your Building Powerful Mathematics workshop.
Y'all, registration is only open 3 times a year, and you don't want to miss out.
Visit mathisfigureoutable.com/action to select your choice of workshop. You'll gain access to world-class professional development with me that will help you make a lasting impact in your students' lives.
Save your spot at mathisfigureoutable.com/action. We'll see you on the inside.
Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are super cool human achievements, but y'all, they're terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
Y'all, thanks for joining us to make math more figure-outable.
But my very favorite is when you say, "Oh, shoot," and then you start talking.
Did I say, "Oh, shoot"?
You did, like right before we started doing the intro, and I didn't know if you like dropped a pen or what's
I don't even know what I did. I think I need to take a drink. I'm going to take a drink of
Okay,
water.
that's good.
Of
Oh,
water.
good. Well, I found a podcast review that's actually kind of recent, and this is from DVLCATRNG. When I see TRNG, I'm like, training? What's training?
I think it's training. It's develop CA training.
California training? California?
Maybe
I
develop.
don't know.
Cat training. Develop call training. Develop
I don't know.
Catatonia. What's another CA? California? Is California the only CA?
I don't know.
There's got to be a country CA. Canada. Develop Canada training.
Oh, maybe. Okay, well, you have to let us know if this is you. This person said, just-in-time learning. I was not a podcast person until this year.
Bam.
Listen, can I be honest? I have to force myself to listen to podcasts.
You're still not a podcast person?
Mostly because I like quiet in the car, and when I'm running, I need music. Otherwise, I'm not listening to much.
Oh, it just depends on the state of my brain. There are times where I'm like, I need something else happening right now, or I'm going to spin out.
Yeah.
And so, then I have to, and then it has to be 1.5 or because it's.
Oh, for sure. Yeah. I try really hard to listen to, there's some great math podcasts, but anywho, not a podcast person until this year. I'm a high school math teacher for 27 years who moved from being a mimicker to wanting my students to reason and explain their thinking without knowing that was what I was doing. This podcast helps me continue my journey to help more students think and reason. Thank you, Kim and Pam. I look forward to binging this podcast.
Oh, that's amazing. Especially high school teacher. I love it.
Yeah,
I love it.
I was going to say. I love hearing people who have taught 27 years at the high school level being open to learning more. I think it's fantastic.
That is amazing. Thank you so much.
Yeah.
Okay.
Hey, today is a super fun episode. Picture.
They're all super fun, Kim. Come on.
Well, yeah. This one is.
Should we vote someday which ones were not your favorite?
Oh, probably. Yeah.
You're
we should
hilarious.
we should have a top 5 for each of us, and like I wish that hadn't happened.
You really have. I wish I didn't happen.
No, gosh,
I'm going to be thinking about that all day today. What were the ones Kim wished would have happened?
I mean, honestly, we just put stuff out to the world. Honestly, like we put videos out of us teaching. We talk about all the things, like the shame and the embarrassment and the like joy, like whatever. It's gone.
Had to go with. Do you know? I have to tell you. So really, really quick. What is her name? Oh, it'll come to me. Maybe she's out of Houston. I saw her present forever ago. Juanita Copley. I got it. Juanita Copley.
I'm very good.
So
okay.
I'm pretty sure now that I've said her name, this is a positive. Yes, this is a great thing. It totally, I had to think for a second because I was like talking before I thought. So I never do that. She gave a presentation forever ago. I was super young, and she showed video of her teaching young children. And I remember she said something about, I'm not going to quote her correctly, but she said something like thinner Juanita and fluffy. You have to get over that. You have to get over the fact that you're going to change. And God, Kim, sometimes in our coaching group, I'll look at the videos that we've posted, and it's like Pam with pink.
They all have a thumbnail of you.
like all these thumbnails of my Pam with hair down, Pam with straight hair, Pam with wavy hair. It's like, oh, it's just
I
like,
know.
oh, so yeah. Anyway, you have to give that up. Okay, moving
Yeah.
on. Let's dive into today's episode.
Okay.
What in the world are we talking about?
Well, so today we're going to talk about word problems, which I think is a great topic. I think a lot of people deal with either loving or hating word problems. And as I'm laughing a little bit inside because as we said, okay, let's talk word problems, I actually loved word problems growing
You
up.
loved them.
I
All
did.
right. Yeah.
And I thought, I'm picturing like a paper 1 through 29 odd, and then there was always like the 4 problems at the bottom.
4
Right?
star problems.
Maybe,
Yep.
maybe 2, maybe 4. But
And
when
they were the word problems,
Yep,
right?
they had
They
like
were
a
the
little
story
box.
problems. Yep.
And so I never had an issue with them because I found them like a little bit more intriguing and interesting than the boring 1 through 29 at the top of the page. It was like, oh,
Ah.
finally, you're going to give me the story. I don't have to make one up about the problems that I'm doing. Like,
Wait. You're saying you were making up stories about 1 through 29 odd, the
I mean,
naked problems?
I don't think all of them,
Just to be
but
really clear,
I
most
was
people
like,
didn't do that, Kim.
well, I mean, I was thinking about the problems. And so, like, if it helped me to think about what was going on, and then I would like create a story. But at the bottom of the page, like, that was done for me. So I would just like read the story and I'm like picturing what's going on and I'm doing the thing.
Oh, that we could create more of you.
You didn't do that.
Heavens no. Now, that's not to say I didn't enjoy word problems. I enjoyed them for a different reason, and I'm not
Okay.
proud of this, but I was one of the only people who was able to figure them out, and so it was a self-esteem boost for me.
Oh, like they
So
were hard for kids. I never understood.
So it was less about these are cool, and it was more about I'm cool. Now,
Okay.
again, I'm not super proud of that because now I realize I was more fake mathing.
Yeah.
But I'm also going to suggest that if you're rote memorizing and mimicking stuff, word problems are completely different than the naked problems.
Yeah. It wasn't until I was a teacher that I realized that. It wasn't until I was a
That's
teacher
interesting
that I
because
was
they weren't
like,
for you. They weren't
they
completely
weren't.
different for
They
you.
weren't for me. And I could instantly go, okay, well, if the reading, the language was difficult, then that made sense to me why those were more challenging. But as far as like the mathematics behind them, like I didn't until I was a teacher, I was like, that's why these are more challenging for kids.
So
Because it just wasn't for me.
let's start this episode by suggesting. Are we in the middle? By suggesting that we actually our goal is for naked problems and word problems to kind of be the same.
Yeah.
That's our goal for students, because I'm going to just put out there, if we teach reasoning, if we really help kids develop their brains to reason mathematically, then they are reasoning in a contextless naked problem and in a context word problem, and the reasoning is the same. So I get it that for most of us, word problems were completely different because you memorize these rules and did these procedures, and then all of a sudden you came to words and you were like, which one do I do where? Are these Kim, when I was very first teaching, is actually right before I got my first teaching gig. I did a long-term sub gig for a couple of weeks in alternative high school. And when I got in, I taught, I don't remember if I was teaching, but the part I remember was the gal that came back to me for help. And she said, so a high school student, and she goes, "Ma'am, miss, were these the ones we did on Tuesday or the ones we did on Wednesday?" And I said, "What?" And she goes, "Well, if they're the ones we did on Tuesday, then I know you do this. But if they're the ones we do on Wednesday, then you do that thing." And I was like, oh my gosh, you're putting so much mental effort into like categorizing on the day you did it and what the rules were. You can actually just think about the problem. Like if you just like actually tried to make sense of what was going on. So that's why if they are completely foreign, it's now you have to like sort of guess. That's why teachers dive in and try to have kids memorize keywords, and why we better practice all the sample questions from the high stakes tests, because if they haven't seen this exact question worded this way, they're going to get thrown off. They better see that a lot so they can sort of memorize their way through that question. Does that make sense, Kim? Like if they're completely separate, and word problems are this different entity, and I have to guess and flip a coin about which algorithm I'm going to do when.
Yeah.
Then we better have all this other stuff happen. And I'm just going to mention that I appreciate Dan Meyer's work where he says, remove all the unnecessary work. Let's not, I think you just kind of said, if reading and the language is a difficult thing for you. I mean, I have a daughter with dyslexia, so that's a thing.
Yeah.
Then we don't want the burden of language
Correct.
to impact the mathing that you can do.
Right.
So we want to keep all that alive. But here's maybe the biggest point. The bigger point is, in reality, we need kids diving into making sense of phenomena and situations and realizing, is this context here additive? Is it multiplicative? Is it proportional? Like, what's actually happening here? Even super young kids that are still in counting strategies. Like, are the puppies coming in the room? Are they leaving the room? Am I popping the balloons? Are the balloons flying away? Am I blowing up balloons? Like, what's actually happening? And feeling the phenomena, actually the occurrence that we're representing with numerals and equations and functions and graphs. Like, when they're diving in and making sense of all that, then I would suggest we get more of what you were doing, where they're the same. And maybe they're making up their own scenarios, their own situations to those naked contextual problems. The best way to teach word problems is to teach reasoning.
Yeah. So I'm going to take you back to maybe my childhood. So
just a few years ago.
Yeah, just a few, maybe 4 or 5. And because I played with numbers, when I would get a piece of paper that had 1 through 29 odd, I didn't own all the most sophisticated strategies at that point, but I played with number. And so when I looked at that paper, I would go, okay, which ones do I want to solve first, or in what order? And there was a little bit of like playfulness to the paper. I didn't always go 1, 2, 3, 4. And so I would look for like categories of numbers.
You're such a rule breaker.
I didn't, people do this, right? Like, I didn't go in order. I looked for like what types of problems had some similarities to them. And I would do maybe those kinds of problems. And then, so there was examination, there was playfulness, there was categorizing. There was, when I got into a type of problem, then I would go like, how do I want to mess with the numbers? Do I want to, I did maybe in my early years, a lot of adding left to right. And so I was kind of tinkering and holding number and jotting some things down. And so the time that I was spending on average in a 1 through 29 problem was maybe a little bit more than somebody else who was stacking and following steps, because, people could do that pretty quickly. And then when I got to the problems at the bottom, for me to read them and like consider them and think about how I want to solve them, it was probably a bit longer than 1 through 29 odd, but I don't know that it was like that much longer. So in the work that I was doing in the first bit of the page, like, I already had a little bit of stamina for working on math. Like, I dug in and I did some things. And so I want to juxtapose that with my very first year teaching. We've talked a little bit about distortions. And one of them for me was that I understood math and I did math and I played with math, but I didn't really, I knew that lots of people did or didn't. Like, it wasn't something that we talked about. And so I was like, hey, when I teach, I must teach the way that I was taught. And some people will do the things that I did and some won't. And so when I taught, it was very traditional. And so in the 1 through 29 portion of the paper, I would teach kids that first year or two to do some traditional steps. And when my kids could do those quickly, they were just banging those problems out. And so when they got to the last few problems and they had to like actually engage with them for a longer amount of time, I would see kids like quit on it. Like, if it didn't have a subtraction symbol or an addition symbol, or they had to like really like put some mental energy into it, I would see kids just kind of like give up. And that didn't make sense to me in my first year, because I was like, let's read the thing. And these are kids that like had some reading skills, and that wasn't the challenge, was like reading. It was that they were like, I don't know what I'm supposed to do. And this feels like it's taking too long. And I was just struck by their lack of stamina, their lack of willingness to dive in and to tackle. And so when you say kids, the best way to teach word problems is to teach reasoning, I am 100% on board for a couple of reasons, the most of which is that we give kids the opportunity to just hang on, to like give them something to chew on, so that they understand that math is about like working on and working with,
putting forth mental effort.
Yeah.
Not just putting forth effort to mimic.
Yeah.
Different. Those are different mental actions. Mimicking steps, different mental actions than
for sure.
reasoning through, using relationships, logicking your way through.
Yeah, for sure.
Yeah. So when I'm aware that we both just said something like the best way to teach word problems is to teach reasoning. And that might sound like the best way to teach word problems is to give them some problem solving strategies, like Polya's sort of thing, you know, like what's reasonable. And that's not what we mean. So let's dive in and do an example of when I say the best way to teach word problems is to teach reasoning. Well, in fact, let's illustrate that. But let me say one other quick thing. Sometimes people will say to me, Pam, you sure do an awful lot of naked number stuff. Where are your word problems? And I'll say, oh, that's because to me they're like the same. Like I'm going to help you reason additively, multiplicatively, proportionally, so that when you are in additive situations, your brain is reasoning additively. So let's do an example of that. So let's say that we're suggesting that you teach reasoning for a problem like 36 plus 19. And so if we are working with kids and we're helping them learn reasoning, then a kid is going to attack that problem not by saying, "Ooh, I better line those up. What did my teacher tell me on Tuesday? I start with these small, not those steps." But rather, if we've been teaching reasoning, then a young student goes, let's see. Well, young. I said young because in my head I'm like, they haven't. Their first gut instinct isn't the algorithm, so we've sort of caught them. We're teaching reasoning. That first young student is going to go 36 plus 19. All right, what do I know about 36? I have some sense of it's more than 30 and it's less than 40. And it's kind of in this area, and I kind of like 36. Like I have this sense of the magnitude and where it lies and kind of neighborhood and nearness to things enough to go, but now I'm adding, it's gaining. I'm going to the right on a number line. It's getting bigger. I have this feel for this additive thing that I'm getting bigger. 19. What do I know about 19? And one kid might go, let's see, if I'm supposed to get bigger than 36, I can get bigger by 10. And a kid might add 10 and then know that they're going to have to add the rest of the 9. Or another kid might go 19. Starting at, I can picture 36, but I'm going to add 20. I'm not going to add 19. I'm going to add too much. That kid might think I'm going to go a bit to add 20, and then I'm going to have to adjust from there. But another kid might go 36 plus 19. 36, I know where that is. But 19, I know where that is. Man, if I had like these piles of marbles, 36 and 19, I could just move a marble, and I'd end up with 35 in this pile and 20 in that pile. 35 and 20, I have some feel for 30 and 20, and I got this 5 left over. Like all of those feelings, that gut intuition that I'm pulling things together. I'm getting bigger than 36. I wish you could see me. I'm doing all these actions in the air. When a kid then hits a problem and they're like, I'm on page 36 and I need to read 19 more pages tonight, or I've read for 36 minutes and I need to read 19 more minutes, or God, give me another one, Kim. For you. Yeah, I'm thinking about Kim. I've ran 36 miles. And I need to run 19 more miles. Maybe it was kilometers.
Maybe minutes.
Okay, minutes. Okay. Like pick your thing. When a kid hits that word problem, now they're like, okay, I've been in this cognitive space before. I have thought about starting at 36. Whatever's happening, I'm gaining. I'm feeling like this is adding on. I'm going to the right on a number line. 19. What can I do with that 19? If we've literally helped them build those mathematical relationships, when they hit a word problem and the word problem says, you're on page 36 and no, that's bad. off the cuff. And you have $36 and you give Kim 19. I don't know why Kim needed 19 in my dollars.
I'll take it.
Then all of a sudden that felt different.
Yeah.
And I didn't have to memorize. Give is one of those key words. Loan is one of those key words. Slipped under the car seat. Like you can't memorize all the words that could ever be that slipped under car seat was the weirdest one I've ever used. What would be
like losing change in the 80s.
There you go. Losing change. Yeah. Okay. Yeah. I'm old. It's true. When I'm in a word problem, in a story problem, in a context, and I feel the action that I have felt before, now I just continue to reason about it.
Yeah. What you were describing right now is like, it's taking me in a place, like to a place in my head where I'm like, yes, this is how it feels. Like, this is exactly Like when I look at a problem, it's just like I just like zone in and just get so entrenched in what is happening. And it is like it's so being cognitively involved, both in understanding the magnitude of the numbers like you described and how you're feeling about the operations. So when somebody's reading it, the feeling comes out, and I am so happy that we are helping develop that in students, because it's how I felt, and when I talk to my kids it's how they feel. And I just think many, many, many more people deserve to like feel that ownership of the things that they're looking at.
Feel the phenomena, feel
Yeah.
the operation, feel the sense of, for example,
Yes.
if I'm in, I was about to tell you where in the curriculum, but I'll just say, if I were to say, hey, it's 4 scoops to 5 gallons for this recipe, and it's 3 scoops for, I should have made this up earlier, 4 gallons for this other recipe, which one's more orangey? Then I want a kid to go, ooh, it's like 4 to 5 and 3 to 4. This feels like when I've thought about equivalent oranginess before. This feels like where I've thought about equivalent situations where if I scale the amount of scoops, I've got to scale the amount of water in order for it to be the equivalent oranginess. This feels like other situations where I've felt this idea of scaling in tandem. Ooh, it feels like I could do that here. I'm feeling the phenomena of equivalent ratios, and ooh, where have I done that? What have I done? And because it's not ooh, what word have I memorized, and so what form am I going to plug it into? But I'm actually feeling the sense of ooh, it's like this ratio idea. And do I want equivalency? Do I want more than? Do I want more orangey? Well, I've done that. I can feel that in order to do that. Then I have a sense of what that would look like.
Yeah.
It's almost like if I have really built in kids proportional relations, and a kid can say, well, yeah, I have a feel for what y equals 27x feels like it's 1 to 27 and 2 to 54 and 10 to 270, and I can see that line. If I graph it, it's steep because it's 1 to 27, like that's a steep rate. When they feel that, then there might be a day where they look at data and they see 1 to 28 and 2 to 55, and they go, whoa, that almost feels like 1 to 27 and 2 to 54. It's so close. 1 to 28 and 2 to 55. How close is it? Well, both points just shifted up one. And if you could see my body, I just took my arm to be a line in the sky, in the air. Where am I? And so I've got this line, and both points and I just shifted my arm up one because both points just shifted up one. Ooh, well, I've done that before. I've felt where I've had data shift, and I've had linear equations be the model for that data. And when we shift it up, oh, I know what that looks like. That looks like in a function where I've just taken that f of x and I've just added 1 to all those values. So I could say that if f of x was my original function, then f of x all plus 1 is that transformed function. So there are times where, let me give you one more brief example. And I think I've told this story a little bit, but I'm going to tell in a kind of a different purpose today. One day, my third, who probably had the best teaching of everything because I'd worked with his teachers the longest, and he had yay, came home as a senior. He was taking calculus and physics. And he said, hey, Mom, I need your help. And I was like, okay, yeah, like whatever. And he goes, yeah, angular velocity and momentum. And I thought to myself, I haven't done that since high school. I never taught it. When I took it in high school, it was a small part of a test. I never really understood what was going on. I memorized my way through it. I may have even missed those questions on the test, still got the A, whatever. So in this moment, now this is still early. This is where I've done work with younger grade teachers, and I'm starting to do work with older grades. I'm really turning my attention to secondary math, but I kind of haven't done a lot of work there yet to really teach the way we are now advocating. And he says, I need your help with this. And I was like, oh, ask me after dinner. And I think to myself, I just kind of hope he forgets and he'll just ask his teacher tomorrow and whatever. Because I've never done it. Well, after dinner, he doesn't forget. And so he says, hey, Mom, I need your help with this. In my head, I was like, okay, then I'm going to need the formula. And my goal is to look at a couple of examples and see where I'm going to put the numbers in the formula. And then I've got enough algebra that we can then solve for the missing value or whatever. That was it. Not because I meant that to be in my head, but because in the moment to moment decision making, I leaned on my prior experience, and my prior experience with physics was you find the formula and you plug stuff in. And he goes, I said, so, oh, you need help? Okay, fine. Go get your textbook. And he goes, textbook? I think I have a physics. And I was like, seriously, go get your textbook. And he's like, Mom, we don't need the textbook here. And I was like, dude, I haven't, all the things. I haven't taught this. I've never taught it, and I haven't done it since high school. I didn't understand it when I did it. I'm going to need your textbook. And he goes, just help me understand the question. So y'all think of a word problem. It was totally a word problem. It wasn't a naked formula, whatever. It was a word problem. And he goes, just help me see if we can understand what's going on. And so I was like, fine. We pulled up the problem, and he goes, okay, this. And I was like, yeah, so then that. He goes, okay, then I think this, right? And I was like, well, but and this, wait, that? And he's like, ooh, but then it would be this. And then that's the answer. And I was like, oh my gosh, physics is figure outable.
Yeah.
Like it was in that moment where I was like, duh. Like it just because I hadn't thought about it before didn't mean that it wasn't figure outable. But maybe more important for today's episode, it was a word problem where I thought, here's how my experience was, here's how you do these physics word problems. You pluck the numbers, you put them in the formula where they go, you solve for it, and you're done. Or actually, it's figure outable. I just needed to feel the phenomena of angular velocity momentum, and bam, we could go from there.
And I'm going to wonder, maybe this is not true, but I'm going to wonder if you thought you were going to plug in some stuff and do it. I'm quoting, do it.
Yep.
But really, because you two owned equivalence, when you said this, so this, I'm wondering if that was where you were thinking about equivalence.
Could be.
And so, we talk about this a little bit with young students that when we're talking about additive and multiplicative proportional strategies, let's just stick with the 4 operations. The equivalent strategies are the most sophisticated. And I think it's because to own deeply equivalence takes some, it's weightier, right? It's, you have to understand the situations.
More cognitively complex.
Yeah. And in order to really understand the situation and to be able to manipulate it, that takes it's more complex. And so like, if you have a problem like 12 times 18, you might say, okay, it's got an equal sign. And so I'm supposed to find the answer. But in order to think, well, that's equivalent to something like 6 times 36, you have to be involved in understanding what 12 times 18 is.
You just did that really fast. Sorry, keep going.
Okay. No. Okay. So 12 times 18, you have to recognize that's 12 18s. And I could find an answer to 12 18s. But also I could know an equivalent problem is 6 times 36. 636 is equivalent to 12 18s. And so you might manipulate that number, manipulate that problem, and with equivalence to say, I'm going to find a different problem that I want to solve. And those strategies are complex, and they take kids who are thinking and reasoning. And it's about the 12s and the 18s and the relationships between the problems. And so when kids have been asked to reason, they're able to do that kind of work. And it starts by saying equal doesn't mean just do it. It's about building equivalence in your students.
Yeah. And you had me thinking about, if I can think about 12 18s as half as many groups that are twice as big, 6 groups of 36. It's kind of a way that you can, and to do that, we're sort of, like you said, kind of outside the problem almost. It's not like do it. The equal sign means do it. The equal sign means find something equivalent. What do I know? How could I reason? We want to put kids in reasoning land. So everybody has the opportunity to think like Kim just did. And if we're in reasoning land, word problems kind of become a non-issue. They become just the same as everything else. We'll have to take the reading, we have to help kids read a little bit.
Sure.
But if we take any difficulties with reading out, it's just, we're still reasoning. We're reasoning everywhere because math is figure outable. All right, y'all. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figure Outable movement, visit mathisfigureoutable.com. Thanks for spreading the word that math is figure outable. Okay, y'all, did you hear the announcement? Workshop registration, the Math is Figure Outable Building Powerful Mathematics workshops, registration is open now.
It's in these workshops where you will learn all the things you need to make math more figure outable. Select your workshop at mathisfigureoutable.com/action.
Kindergarten through 12th grade educators, we have a workshop for you. Build your numeracy, learn the teacher moves, equip yourself with the knowledge you need to have students naturally engaged in their learning. No matter what grade level you teach, we have a targeted workshop just for you.
Find your best workshop at mathisfigureoutable.com/action.
Y'all, if you think this podcast is good, it's all audio. You want to be involved in the full experience where you can see the modeling and the teaching happening. Let's change the world together and make math more and more figure outable.